Hello, we're here
Uh,
with Daniel Povey, and can you take us through what prepare.sh does in Icefall LibriSpeech ASR? What do
okay, okay. So this does the data preparation before you train the LibriSpeech systems. Firstly, I want to mention that not all of the stages of this are necessarily relevant to all systems. Some of the earlier stages about the language model are mostly relevant to when you're decoding with a graph. And with our latest systems, we don't normally do that. I mean, we can do it, but it's normally doesn't really help. So anyway, let's uh, let's scroll down a bit. It says we assume download dir has these files. If not, they'll be downloaded automatically. So the script is going to do this downloading. Okay, wait. Vocab size is equals. That's the BPE. Can you scroll up a bit? The vocab size is, yeah. We got some numbers commented out there when it's just 500. So uh, the BPE or sentence piece algorithm, they're basically the same. Is a way of splitting up words into little pieces of one character or more, and uh, the number of BPE pieces that we configure is 500. Sometimes people use a lot more, but for us, a small number worked fine. Let's scroll down a bit. This logging function is not important. Okay, the first stage is downloading the LM. This is like the predefined LMs that are distributed with LibriSpeech. These are very old ARPA style LMs. So that downloads that if it's not there. Scroll down a bit. It downloads the LibriSpeech data. Loadc has its own command for doing this. It's just probably getting it from openslr.org. Next, we're downloading the musan data. That's some music and noise data for data augmentation. Then the preparing the LibriSpeech manifest. This is a loadc command that prepares the training manifest for LibriSpeech, which is basically some metadata about where the files are and like what the text associated with them is. The next is preparing the musan manifest. It's the same kind of thing. This is all like inside the loadc package there. This is all pre-done for you kind of. So we don't have to write any code here. Okay, compute fbank LibriSpeech. So in our recipes here, we dump, I think, 80-dimensional filter bank features onto disk, and we compress them with our own like compression method called lilcom, which is a lossy way of compressing matrices. The reason we dump these filter banks is because if we were to extract the audio data during training, it would take up too much CPU because we'd have to like decode the compressed files, I think. And in any case, we'd have to compute filter banks. It would just be a bit slow. And also too much disk I/O because the audio files are larger than the filter banks, I think. Okay. Next, oh yeah, we're concatenating and shuffling all of these JSON-L.gz files. This is just to make sure that we access the training data in random order. I think not all of the recipes actually use this shuffled version of the data because we didn't want to change recipes without testing them. So I think just some of them use the shuffled version, but it's a little bit better to use the shuffled version. Otherwise, you get these like oscillations every epoch. Okay,
and actually
validating. Yeah, go
before
on.
we move on, can you explain up here how does this line work? Because Lotse isn't mentioned anywhere else, and then you're saying Lotse download
Oh,
musan.
I mean, I don't know if we mentioned that you have to like install loadc, but I think it's just like pip install loadc. Loadc is its own Python package, so it should be pretty simple.
Okay.
Yeah. So yeah, scroll down, prepare musan manifest. Yeah, we did all this. Okay, validate manifest.py. That's just making sure everything has the right length and that we didn't lose any data. Okay, compute fbank from musan. That's the same as for LibriSpeech. For data augmentation, we add the two signals at the filter bank log energy level. It's not totally exact, but it's good enough. It doesn't make any difference versus actually adding the audio. Okay, scroll down a bit. Prepare phone-based lang. So like it's a language directory, lang directory similar to Caldi. This is not all of the stuff that we prepare here is actually relevant for most of the recipes. Our latest RNNT-based recipes don't make much use of this file, like the lexicon and stuff. So this prepares the lexicon.txt, adds a couple special symbols like silence and spoken noise. I don't know that those are actually used very much or even at all. Some of them might not be. Then it prepare lang.py. That's probably, what's that doing? It might be converting the lexicon into an FST. Oh, that's the next thing. The line 175. It converts L.pt into L.fst. Oh yeah, I see. Because we previously prepared the lexicon L in in the format used by K2, because K2 has its own finite state processing, and then we're converting it into the OpenFST style, because it turns out that we couldn't manage to implement all the operations we wanted to implement in K2 for FSTs. So we're kind of backing off to OpenFST for some of these. This is, if you're just doing a standard decoding, you don't really need to worry about all of this FST business, because it's not necessary in a normal decoding, but it is helpful if you want to do some certain kinds of model biasing. Like, let's suppose you want to adapt your model with some text from your domain. This FST stuff gives you a way to do that. And I believe one of my guys recently created a page. I forget the specific URL, but it's about how to adapt your model to new language modeling data in IceFall. So it'll be somewhere in the IceFall docs, I think. Okay. Next, convert. Okay, another one. L disambig is the lexicon with disambiguation symbols at the end. These are like symbols like £1 and £2 that we use to remove homophones from the dictionary, so that two words that have the same pronunciation have like an artificially different pronunciation. It's just to avoid some issue with determinization of the FST. Okay, go down. Prepare BPE based lang. So this is so the previous language model stuff was for the setup where your model is done on phones, like things like that. Mm-hmm. And that's the old-fashioned style of doing speech recognition. You could still do it, but these days people have been moving to doing everything on the letters themselves and forgetting about how things are pronounced. So that's what the BPE based lang is. The BPE symbols are like, they're sentence pieces or word pieces, actually. Okay, so for vocab size and blah, we're doing just the 500, I think. I mean, the BPE 500. Generating data. Okay, so this is taking all the data transcripts and turning them into BPE pieces. I think this is for purposes of generating language models on the BPE units. So you can scroll down a bit. train BPE model. Oh, I see. It's just writing the text files, and now it's going to you have to train the BPE model. Basically, it selects which pairs of characters or sequences of characters to make into its own symbol. It's a very simple process, and quite fast. Okay, now next it does prepare lang bpe.py. I think it's just creating a few small files, similar format to the previous lang directory that we prepared on phones. They'll probably have a tokens.txt and a words.txt and stuff. Most of these things aren't really necessary. The thing that's really necessary is the BPE thing that we prepared by like train bpe.py. That's needed for like a lot of things. Okay, so next, validating BPE lexicon.py. That's just to check everything worked. Okay, some of these stages are the same as we did before. We can scroll down. We did these for the phone-based lang. It's just to prepare the lexicon FST. Again, this won't always be needed. Okay, this p.arpa, what this is, we can go back up. So go back up to the max order 3 thing. Yeah, okay, you can stop there. Get down a bit.
Oh, here.
Yeah, here, make knlm.py. KNLM is Canadian Lion Language Model. It's the most popular way of making backoff language models or ARPA language models. We're making a 2-gram phone level or BPE level, sorry, language model. And the purpose of this is to it's for something called low order density ratio. So basically, when we rescore our RNNT system with a language model, we kind of want to subtract a language model estimated on the training data. The idea is that the RNNT already has its own internal language model, so it's not really expecting you to add another language model when you decode, which is what you do when you do so-called shallow fusion. So to compensate for the fact that it doesn't really want a language model, you kind of subtract another language model, a basic one. And the idea is that the basic one is trained on the training data itself, because when you supply a language model, it kind of conceptually represents the difference between your training domain and the new domain, like the log ratio or something. So that's the purpose that we use that for. You can scroll down a little bit. We also make some higher order language models. These were probably just for testing various things.
Max order equals 2.
Oh, that must be the basic one. I think we're doing that for 2 different language directories or something. I don't think it's that important. Next, let's see what this is. Okay, so this one is using the words symbol table. This is creating a word level language model. It's for building a graph where you have a lexicon and words, and well, we don't use H, we use T because it's probably a CTC system. It's a simpler topology. But this won't be used in most systems. The prepare script does it anyway because it's shared between all the recipes. But yeah, we dump this language model. For RNNT, we don't really need this. Let's scroll down. Same with the foreground. This is just a larger one that you sometimes want to rescore with. Keep going. Yeah, this is again about language model, about decoding with language models. This one could be used, for instance, with some kind of CTC system, I think. And you can also decode RNNTs. With RNNTs, I think you use an LG, not a HLG. because RNNTs, you don't have the repeated symbols like you do in CTC. So you don't need to account for that. But yeah. Okay, let's go down. Keep going down. This is more graph stuff. Okay, generate LM training data. Scroll down a little bit. Yeah, this is okay. The LG is used. This is what we use for RNNT decoding when we choose to use a language model, which we don't have to. Okay, prepare LM training data. This is preparing, it looks like it's preparing data for training a language model on BPE pieces using the LibriSpeech. I think this is the LibriSpeech text data that isn't, we don't have audio for this. This is some extra data that we distributed with LibriSpeech for purposes of people building language models. And in the end, we're going to, I think, build an RNN-based language model on this. Our RNN language model recipe is a little bit outdated, unfortunately. We have much better things that we can do. And at some point, we're going to fix that, but it's not super necessary. So we haven't put a lot of importance on it. Okay, validation data. This is just about the train valid split, so you can figure out how good your language model is training. Okay, scroll down. It's just forming a train valid split. It's not rocket science, this part. Prepare LM training data.py. Again, let me see what's going on here. I think this is just some change of yeah, we have a special way of preparing the data. It's all like in it's all integerized for fast access. I think lately we've gone back to using simpler ways of loading the data. But this is how we chose to do it when we wrote this script. Okay, scroll down. Generate LM test data. Let's see. Oh, this is for test clean and test other, so that we can evaluate how good our language models on the real test sets. Again, this is just for validation stuff.
Okay.
Let's keep going. And like reporting numbers for papers, this is what this is for. Okay. Like when you report perplexity for a paper. Okay, sort LM training data. We're sorting it. So some language model training recipes for RNN LMs, they may be starting with shorter sentences. It's also possible that we sorted it in this order because we wanted, oh, I think I remember now. We wanted to create batches with the same length of utterance, so that we wouldn't have to do padding when creating the batches. That's what this is about. And then I think we're going to randomly select different sentences or different parts of this long array. Okay, keep going.
That's the end.
Yeah, this is about language model training. This again is not super important. Language models are optional. Keep going.
That's the end.
Sorry?
That's the end.
That's the end? Okay, fine. So all of this was the data preparation. Probably the important thing is if you look in the README and go to the end, there'll be something about a zipformer. That's the go click on ASR and then click on readme.md. No. Scroll down until you see README.
This one?
Oh yeah, this is the README. Yeah. So you can just scroll down. Yeah, it's displayed here. Oh, okay. So this summarizes all the different recipes. The zipformer is the important one, just before the CTC section there. That's the latest recipe. And it'll probably give you the command how you run it. if you scroll down to the bottom, or possibly it's in like results.md, it'll give you the command to run it. It's not that complicated. It's like zipformer / train.py with certain arguments. Yeah.
If I just want to make a BPE model,
Yeah.
parts of this script would I need?
Oh, okay. Look for the thing where it says train BPE or something like that.
I think that's step 6. Pair BPE.
Yeah. Okay. So I think there's a step before the train BPE thing where it creates a file that has the transcripts, and that's just a text file with each line is one sentence. And I don't think that's even important that there's one line per sentence. The point is that all the training text is in there.
In stage 5?
Maybe there's some stage where it just puts all of the language model training data in one file. No, it's not that one. It has nothing to do with the lexicon. Probably further down.
Down or up?
Down. Like it's probably in stage 6, like you said.
Oh.
Yep, keep going. Yeah, here. So
Where?
well, there was a find command with something star.trans.txt. That was
Oh, this one?
okay, that train BPE model is where it's training the BPE. I suspect that the langdir is somewhere where it outputs stuff. This find is just listing a bunch of file names, but then below that, in the for loop, it's like catting them to the output, and then it's removing the first field, which is the utterance ID, and then it puts them all in one file, which is transcript words.txt. So if you have some text data that's like your text data, you might want to use that one instead. And also, I kind of recommend to use the byte failover option equals true, because what I'm concerned is if your data is not very clean and it has a bunch of foreign characters or weird symbols, I'm concerned that unless you use the byte failover option, BPE is going to allocate a bunch of symbols for like weird characters that are super rare, which you don't really want that.
Where's byte fail?
Oh, it's an option to Google sentence piece module. I don't know the exact interface. You might have to go into that script. It's probably not exposed by that train BPE model.py. You probably have to look into that script and give an extra arg to sentence piece. No, so I think it's byte fallback is what it's called, or fallback to byte, or fallback bytes.
Okay.
Yeah. Cool.
So you think I just need step 6? I don't need any of the previous ones? Or
yeah, probably train BPE model.py, yeah.
okay.
Because only really the BPE is needed by the zipformer training script. Yeah.
Okay. Thank you. That was David Povey.
Oh, and you also need the tokens.txt, which might be created by the like prepare lang BPE or something like that.
Okay.
Bye.
Bye-bye.